All right, we're going to spend a little bit of time now differentiating between different types and ways to describe lipids. So one way is to describe a lipid as saturated. Saturated lipids have the maximum number of hydrogen atoms possible, which means they have no double bonds in their carbon atoms, or in their long carbon chain. Generally, if a lipid is saturated, it's solid at room temperature. So think about the difference between like butter on your counter versus something like olive oil on your counter. Butter would be the saturated lipid. Unsaturated lipids do not have the maximum amount of hydrogens in their carbon chain, which means that they have one or more double bonds. Oils are liquids at room temperature. When you hydrogenate those oils, by adding more hydrogen, they become solid and saturated. So here's what you might see the structure of a saturated versus an unsaturated fatty acid to look like. The saturated fatty acids, because they have no double bonds between their carbons and maximum number of hydrogens, you get this long straight chain. When you get the double bonds between the two carbons, as in an unsaturated fatty acid, you get these kinks in the chain. The chemical process that is used to saturate unsaturated fatty acids, so putting those hydrogens into the unsaturated fatty acids, can lead to trans fats. Trans fats have a double bond that is rotated, resulting in a linear chain. So that's how you end up with that solid structure at room temperature, because you get this twisted double bond that straightens out that kink in the chain that was there before. This twisted double bond does not function well in biological systems, and we now know that they are a health hazard. So this is the structure of a trans unsaturated fatty acid, or a trans fat. One example of a trans fat is margarine. Margarine was developed during World War II. Due to a milk and butter shortage, scientists took corn oil and hydrogenated it. The double bonds became single bonds and a solid was formed. Trans fats tend to stay in the bloodstream much longer than saturated or unsaturated fats. Because of this, trans fats are much more prone to arterial deposition and plaque formation. Trans fats are thought to play a role in the following diseases and disorders: cancer, Alzheimer's disease, diabetes, obesity, liver dysfunction, and infertility. Another example of amphiphilic lipids are soaps and detergents. The hydrophobic end of a soap or detergent is repelled by the water, but attracted to other nonpolar molecules like grease and oil that may be on your hands or your clothing. The hydrophilic end of the soap or detergent hydrogen bonds with the water. So in this process, the soap or detergent bonds with many stains, oil, grease, and other hydrophobic things, and pulls them from the surface being cleaned and into the surrounding water. The water then goes down the drain along with the oil or grease, leaving the surface clean. Waxes are effective hydrophobic coatings formed by many organisms, insects, plants, humans, to ward off water. They consist of one long fatty acid attached to an alcohol. Steroids are lipids with backbones which form rings. Cholesterol is an important steroid, as are the male and female sex hormones, testosterone and estrogen. A couple of other steroids here we see cortisol and vitamin D3.